Welcome to my channel, friends. Remember, on my channel I usually post more advanced math videos. So here's a nice limit question. Let's do it. The limit as x approaches 0 from the right side of x to the x and the whole thing raised to the x again. What can we do here? Well, this is a base, isn't it? So we can use the famous trick that says it's equivalent to the limit as x approaches 0 from the right side of e to the ln x to the x, and then this other x here double underlined, I'm going to put that all the way out here. So this is allowed because e and ln are inverse functions. And then from there, you have the limit as x approaches 0 from the right side, and like this x right there, lightly underlined. By the power rule, you get e raised to the x times ln x times this double underlined x here. Now, this one and this one, you can multiply them together. So you're going to have the limit as x approaches 0 from the right side, that is, and then multiply those to get e to the x squared ln x. Now, in case you don't believe that all of this is valid, how do you check it? Well, this is what you can always do. Take x to the x to the x, graph it. Take e to the ln x to the x times x, graph it. Take e to the x ln x times x, which is e to the x squared ln x, graph them, and you will see they all represent the same picture, which means they are all equivalent. These moves are all valid for that reason, you see? In other words, there will be only one graph for all of these steps. That graph, roughly speaking, kind of looks like this. You can check for yourself if you like. For all of these, it's the same graph. So I know this is all valid for that reason. Anyway, we'll go on to this next. Here there's a competition. Well, what's the competition? It kind of looks like this. If you graph x squared by itself, independently of the ln x, it looks like this, right? So this is x squared. Now graph ln x. So that looks like this, independently of the x squared. It goes towards negative infinity. So since x is approaching 0 from the right side, this is going towards 0, but this is going towards negative infinity there. In other words, you have a competition of the form 0 times negative infinity. When we've got that, we got to use our friend L'Hopital, right? But first we got to rewrite. So the limit as x approaches 0 from the right side of e, and then we write that as ln x over 1 over x squared. Now this is a slightly different situation when it comes to these graphs here. So this is what I mean. Graph the following. Graph ln x by itself. It looks like this. This is ln x. But then graph 1 over x squared. When you do that, you realize quickly that it looks like this. So this graph is 1 over x squared. So this is going towards positive infinity. This one down towards negative infinity. Now we have what we need for L'Hopital's. We have a competition between negative and positive infinities. That's perfect. Let's take it from here. Now differentiate the top and the bottom independently. And also we can bring the limit inside because e is continuous. So we're going to have e, and then you have to write kind of big here. And the limit as x approaches 0 from the right side, differentiate ln of x. That's just 1 over x. Differentiate 1 over x squared in the bottom independently of the top by L'Hopital's. So that's going to give you, well, it's like the following, right? 1 over x squared is x to the negative second. So when you differentiate by the power rule, you're going to have negative 2, and then you subtract 1, giving you negative 3, but then it goes into the bottom as positive 3. So you have 1 over x divided by negative 2 over x cubed. And then from there, keep, change, flip, right? So e limit as x approaches 0 from the right side. And then when you flip this, you're going to have 1 over x times negative x cubed over 2. Now we know what to do. Like this will cancel, leaving a 2 here, and then you have negative a half. So you have e, and then the limit as x approaches 0 from the right side of negative x squared over 2 pretty much. And now we can just do it with direct substitution. So you're going to have the e, and then direct sub says it's going to be negative 0 squared over 2, which is e to the 0, which is 1, and that's the value of the limit. I love these kinds of exercises. If you like more advanced math at this level, please be sure to like and subscribe.